You ever wonder how a database can possibly keep up with our messy, complicated world? I mean, really think about it. Well, that's exactly what we're diving into today. We're going to look at a super powerful blueprint called the Enhanced Entity Relationship Model. Think of it as the secret weapon for building clean, logical databases that can actually tame all that real-world chaos.
I mean, the real world is anything but simple, right? It's just full of categories and exceptions and all these little is a type of relationships. A car is a type of vehicle. A manager is a type of employee. You get the idea. So the big question is, how do we get a database, a system that absolutely loves rigid structure and rules, to actually handle all of that beautiful, messy nuance?
Okay, so a basic database model, it's totally fine for storing general info about, say, an employee. No problem. But what happens when you need to store unique details for different kinds of employees? Like a secretary needs a typing speed attribute, but an engineer needs an engineering type. All of a sudden, that simple one-size-fits-all model just breaks. It doesn't cut it anymore.
So to get our heads around this, here's the plan. First, we'll see exactly where simple models fail. Then we'll bring in the EER model upgrade. We'll get into the key concepts, like superclasses, and cover two really critical design rules. After that, we'll actually decode a real diagram, and we'll wrap it all up with why any of this really matters in the first place.
All right, first up, let's really dig into the problem here. We need to see exactly where the standard entity relationship diagrams, you'll usually just hear them called ER diagrams, start to run out of steam. You know, a standard ER model is fantastic at defining basic things. It can see a big bucket labeled employees and manage that perfectly. But it just doesn't have the vocabulary to say, hey, this secretary is an employee, but she's a more specific version with her own special attributes. It really struggles to capture that crucial parent-child hierarchical relationship.
And this is where our solution makes its grand entrance, the Enhanced Entity Relationship Model, or EER for short. It's the exact upgrade our data modeling needs to handle these more sophisticated, real-world situations.
So what is it, really? Well, think of it this way. The ER model takes everything that's already great about the standard ER model and just adds a whole new layer of powerful tools. The big ones you need to know are concepts like superclasses, subclasses, and inheritance. And they are all designed for one specific job, to model those is a type of relationships we were just talking about. And this really lays out the difference, plain and simple. On the one hand, you've got the basic ER model, perfect for simple objects. But on the other, you have the EER model, which builds right on top of that foundation. It gives us what we need to map out complex hierarchies and, this is the big one, it introduces the absolutely game-changing idea of inheritance.
Okay, so let's get into the nitty-gritty, the actual building blocks of the EER model. We're going to see how superclasses get organized and really unpack this powerful concept of inheritance.
This diagram nails the core idea. We start with a really general category at the top, employee. We call that our superclass. Then from there, we can branch off and define more specific types, like secretary or engineer. These are our subclasses. You can just think of them as specialized versions of the main employee type.
Now, the magic that connects all this is called inheritance. And trust me, this is a total game changer. It means that any entity we define as an engineer automatically gets all the attributes of an employee. You know, the name, social security number, address, without us having to type them all out again. It just inherits them.
Let's just walk through that real quick. Step 1. We establish that an engineer is an employee. Simple enough. Step 2. Because of that relationship, it automatically inherits all the common employee stuff. But then, and this is the key, Step 3. We can add attributes that are unique only to engineers, like eng type. It's super efficient and just makes perfect logical sense.
Okay, now when you're the one designing these hierarchies, you have to make a couple of really important decisions. You can think of them as two critical rules or constraints that are going to define exactly how your categories behave.
So here it is, rule number 1. This is the first question you, as the designer, have to answer. When you break a general category down into more specific ones, can a single person or thing belong to more than one of those specific categories at the same time?
And your answer to that question leads you to two choices. First, there's the disjoint constraint, which you'll see marked with the D. This is an either-or situation. An entity can be a member of only one subclass. An employee is either a secretary or a technician, period. Can't be both. Then you have the overlapping constraint, marked with an O.
This is a both-and world. An entity can be a member of more than one subclass. The classic example is a university, where one person could totally be both a student and a faculty member at the same time.
Okay, that was the first rule. Now for the second big decision you have to make, you need to decide, is it mandatory for every single thing in your main category to also belong to one of the smaller, more specific categories, or can some of them just not be categorized?
And again, this gives us two options. The first is called total participation, and you'll spot this because of the double line in the diagram. This means every single entity in the superclass must belong to a subclass. No ifs, ands, or buts. Every employee must be categorized. In contrast, you have partial participation, which is just a single line. This is way more flexible. It means an entity in the superclass doesn't have to belong to any of the subclasses. Think of it like this. A vehicle could be a car or a truck, sure, but it could also be a motorcycle, which isn't one of those specific options.
Okay, I know that was a lot. So here it is all put together in a super handy cheat sheet. This table combines those two rules we just talked about. So for example, you see a D plus a double line. That means an entity must be exactly one of the types. You see a D plus a single line, that means it can be one of the types, or maybe none of them. This is basically the grammar you need to read these ER diagrams.
All right, theory time is over. We've learned the rules, we've learned the symbols, now it's time for the fun part. Let's put all the pieces together and actually decode a real diagram.
Okay, so take a look at this. I get it, it might seem a little complex at first glance, but don't worry, we have all the tools we need to read this thing. What we're looking at is a diagram for an employee database, and it shows a few different ways that main employee superclass is being broken down. Let's tackle it piece by piece.
So let's actually read the story this diagram is telling us. It all starts with the employee's superclass right at the top. Now, if we follow that branch down to the left, we see a circle with a D and that double line coming out. Remember the cheat sheet? D means disjoint, double line means total. So that tells us that every single employee must be exactly one of these three things: a secretary, a technician, or an engineer. Okay, now let's look at the other branch, on the right. Here we see a D again, but this time it's a single line. That means an employee can be salaried or hourly, but not both. But, and this is important, they don't have to be either one. And check this out. See how only the salaried employee has a relationship to manages a project? Subclasses can have their own unique relationships. It's amazing how much information is packed into just these few symbols.
So let's pull back for a second and look at the big picture. Why do we go through all this trouble? Why does this kind of detailed modeling actually matter?
Well, here are the big takeaways. First, ER modeling lets us capture those messy real-world hierarchies accurately. Second, that whole inheritance thing we talked about, it massively reduces data redundancy. You're not repeating name and address all over the place. This gives developers a much clearer, more accurate blueprint to build from. And finally, it lets you enforce your business rules, like an employee can only be a technician or an engineer, not both, directly into the design of the database itself. It's incredibly powerful.
And that brings me to a final thought for you. The next time you're using any app on your phone, shopping, banking, social media, you name it, just take a second and think about the database behind it. What hidden superclasses and subclasses and inheritance rules are working away behind the scenes just to manage all that complexity? It's kind of cool when you think about it. Thanks for coming along on this deep dive with me.